So once again, good afternoon, grade 8, and good afternoon to everyone. The first module that you have with you right now is entitled Trigonometric Functions of Angles in Standard Position. It is quite clear in the title there that we are trying to find the ratios, the trigonometric ratios of these angles, which are in standard position. Recall the formula for sine, cosine, and tangent. What is the formula for sine, cosine, and tangent? What was the formula there? SOHCAHTOA. And we will use that formula, SOHCAHTOA, in dealing with the values that we need for us to answer a certain problem under the angle in standard position discussion. But before that, let's try to know how to find the value of r. In trigonometry class, r is termed the modulus of a point. R is termed the modulus of a point. Again, in trigonometry, R is going to represent the modulus of a point. Modulus means the distance of that said point to the origin. It is the distance of that said point to the origin, and the origin with the coordinates 0, 0, and the point with the coordinates x and y. Using distance formula, the value or using the distance formula, r squared is equal to the square root of x minus 0 squared plus y minus 0 squared. Ay, there's no square root pala. Wala pa ng square root. So therefore, r squared then is equal to x minus 0 is x, which is now equal to x squared plus y squared, or to find for the value of your r, which is the modulus of the point, then you can just simply get the square root of the sum of the values of x and y. You can also associate this in a Pythagorean theorem. So in this structure class, we have here a point with the coordinates x and y. Alpha there is the angle in standard position. To find the distance of point x and y, or rather point P, with coordinates x and y to the origin, we're simply finding for the modulus of that function, or modulus of that said point. So let the modulus be r. Again, r or modulus is the distance from the origin to the point, or from the point to the origin. We can use here the distance formula, but we can just simply, I already derived the formula a while ago, and allow me to show the final derivation of the formula as r equals the square root of x squared plus y squared. You can also find that in the module. The formula for r is also found in the module for the distance of the point to the origin, or from the origin to the said point. And then for the values of the your, shall we say, sine, cosine, and tangent, we can make a right triangle here, class. So, drawing tag straight line there. Then we can make a right angle. Ay, so if we make a right angle here, class, and then we put values as this is y, because that's the distance of the origin to y, which is located here. And this is your x. Hello? Recalling the formula for SOHCAHTOA again, sine of alpha is equal to opposite over hypotenuse. This time around, your hypotenuse is r. So sine of alpha is equal to y over r. Hello ba? Sine of alpha is equal to y over r. Taken from the creation of a right triangle in the abscissa and the terminal side of your angle. By the way, how will you call alpha here, class? What is the term that can be associated to alpha in an angle in standard position? Alpha here is the R, E. We just
Reference point.
E, reference angle. Thank you. It's not a reference point, but it's a reference angle. And we are all going to base our angle from the reference angle of that said angle in standard position for us to create a right triangle. Get it? So from that illustration as well, to find for the formula for finding the cosine value of alpha, cosine of alpha is equal to adjacent over hypotenuse, and your adjacent there is x, your hypotenuse is r. And for tangent, you can use y over x or opposite over adjacent. The values x, y can be seen in the coordinates. The value of r can be computed from the coordinates. So therefore, all of these are already given in the figure. It is just for you to come up with a better understanding of the angle given in standard position for you to be ready on how to deal with the values of the first three trigonometric functions. Not to mention, we still have cotangent, secant, and cosecant with the formula cow, sha, chu. Question before we proceed. Oh, you understand then. So let's proceed with more of the trigonometric ratios. Since cha is the reciprocal of cosecant and cho is the reciprocal of sine, whereas cotangent is the reciprocal of tangent, which is also found in your module, then the formula for the other uh, trigonometric ratios for secant, or rather for cosecant, is just r over y, the reciprocal of sine. For cosine, it's just for the x and r, the reciprocal to that is secant, so that is r over x. And for tangent, it will give you the formula for cotangent, since cotangent is the reciprocal of tangent, which is still part of your module. Nalagyan po na sa inyong module class. Lingini lang na inyong module. Huh? These are now the formulas, the 6 basic trigonometric functions, the values, or the formulas to find the trigonometric functions of the angles in standard position. We are now trying to combine angles in standard position using reference and coterminal with the 6 basic trigonometric ratios. Using them together, thus we have angles in standard position with the inclusion of trigonometric functions. No problem with the shortcut they have. Let's try this example class. Find the values of the 6 trigonometric functions of angle alpha in standard position whose terminal side passes through point 4 and -5. So to draw the angle in standard position, which terminates it in the fourth quadrant, because 4 and -5 is located in the fourth quadrant. So this is now your illustration. Question before we proceed? Even if you're not going to draw the triangle class, but for as long as you can derive the value of r, even without the figure, you can find the answer to the given problems or to the given or to the instruction being presented. Like find the 6 trigonometric ratios. You already have the x here. The x value is equal to 4. The y value is equal to -5. And for the value of r, you can just use the formula r squared is equal to the square root of x squared plus y squared. And then we already have the value of your x and your y as 4 and negative 5 respectively. So your r is equal to the square root of 41. Just so you know, your final answer should be a rationalized value. Okay? So instead of having the denominator to have a radical, you have to rationalize it. So your modulus r is now equal to the square root of 41. We can now find for the first function, which is sine. Sine function is equal to y over r. Your y is negative 5. Your r is the square root of 41. Though I could consider this as your final answer, but if it is in a multiple choice type of test, what do you think so is the rationalized value of 5 negative square root of 41? Ralph, what is the rationalized value of negative 5 over square root of 41?
Negative 5 square root of 41 over 41.
Very good. So you're going to multiply it, both sides of the equation, for both sides of the fraction by square root of 41. So therefore, the answer is negative 5 square root of 41. And on the other side, we can now cancel the radical sign. We have the square root of 41. Yun. Okay, so just make sure that your answers are rationalized so that it will be considered a final and simplified. For cosine, we can also find the value of your cosine because your x is already given, which is equal to 4, and your y is also at square root of 41. So your answer there is 4 square root of 41 over 41. Tangent y over x, so we have negative 5 over 4. Cosecant r over y, so that's the square root of 41 over negative 5. Second, r over x, that's the square root of 41 over 4. And cotangent, that's x over y, the square root, or rather 4 over 5 negative. So even if you don't have the figure class, even if you don't know how to draw the figure, you can now find the values because of the x and the y and the r are already given. And in your formulas, you don't have any other letters but these letters x, y, and r. Question before we proceed?
Sir,
Yes, Krisha.
where did you get 5 again, sir?
What 5? There's no 5 here, class. It's negative 5.
I
Not
mean, negative 5.
Akin nga, negative 5. Dara. The coordinates of the point. Where did I get 4? Dara. The coordinates of your point. Take note that the point contains the coordinates x and y. Where did I get the square root of 41? Dara. Solving it using the modulus formula, r is equal to the square root of x squared plus y squared. Okay, Krisha. Again, given ra ang x, naara diha sa coordinates. Ang y, naara po diha sa coordinates. Ang r, naara gihapon diha. Just have to solve it. So the only thing you need to solve is r. And if you can find the value of r, every value of your 6 basic trigonometric function is already a given answer. Ako eliminate ang scribbles para you can see the complete
Yes,
solution.
sir.
Okay. Yes, Clarice. Yes, Clarice.
Why did we divide it again by 41?
Well, what again? What was the question again? That's choppy. Why did
Why
we
did we
divide?
divide the negative 5 over square root 41 by 41?
We did not divide it, but we multiplied it. Look at the solution. We multiplied it by the square root of 41 over the square root of 41. We multiplied it, both numerator and denominator, by the same value. Anyways, if you are going to simplify this, that is just equal to 1. It's just as if you multiplied this by itself, applying the concept of multiplicative identity. Didn't you have a lesson in math which is called rationalizing denominators? Wala pa mo, ana? Did you already have a lesson on math which is rationalizing denominators?
Not yet, sir.
Now, sige. So, ako ni solvon ha. So, this will now become negative 5 square root of 41 over the square root of 41 times the square root of 41 is 41 squared. Duha ka 41. Cancel the square and the square root. So your answer is negative 5 square root of 41 over 41. What is the purpose of fractionalizing denominators, class? To remove the radical sign in the denominator. You try to press this in your calculator. And your answer will, the calculator will give you the rationalized value. No calculator will tell you of an answer like this. This is not given in the calculator. Rather, this is the one presented by the calculator because your gadgets will tell you of the simplified, rationalized final answer. Sir, is it possible for us to have the answer in radicals? Yes. If you wish to have this as your final answer, no one is stopping you then. If you can come up with an answer like this, then fine. But just be careful because sometimes in my summative test, I might give you multiple choice where the answers are rationalized. So at least right now, I'm telling you how to rationalize a denominator. Any other concern? Silence means you understand? So we have here this one class. This is the rationalizing of each of the denominators. For those who have the radical sign, we multiply it by whatever the value of the denominator to come up with the rationalized final answer. So as with cosine, we have to multiply it with the same value to come up with the rationalized final answer. Leave the answers with rationalized denominators. Rationalized denominators again means that your denominator should not contain the radical. But then again, if you fail to do so, probably in a 2 points exam, I'll only give you 1 point for a non-rationalized final answer. Quadrantal angles are angles with the sides located on the x and the y axis. The terminal side of a quadrantal angle are the axes. Examples of a quadrantal angle, 90 degrees. That is a quadrantal angle. So if you're going to find the sine of a quadrantal angle 90 degrees, there are values that are undefined. So starting off with sine, your x there is 0, take note ha. Your y is 1, and your r is the distance of the point to the origin. Using the formula r equals square root of 0 squared plus 1 squared. So therefore, your r is equal to 1. To find for sine of alpha, that is equal to 1 over 1 or equal to 1. To find cosine of alpha, 0 over 1 or 0. But for tangent, look at tangent class. What's the formula for tangent? Y over x. Your y is 1 and your x is 0. So 1 divided by 0 is undefined. For cosecant, no problem with cosecant because 1 over 1 is still 1. But for secant class, with the formula r over x, your r is 1 but your x is 0. So secant, 90 degrees is undefined. But for cotangent, this is now equal to 0. Because your x is 0, your y is 1. So the value for cotangent of alpha is equal to 0 for a 90 degrees. You can supply the table class with all the information from 0 degrees to 90 degrees to 180 to 270 to 360. 0 and 360 do have the same answer because they will just go back to the same location. I will not continue this one. Will not. No, these are the values. I'll just project the answers. We will not solve this. It's up to you how you're going to solve this one, class. So these are the answers to each of the angles. These are what we call as quadrantal angles. Quadrantal angles have their terminal side in the x or y axis. Question? Let's proceed with some angles which is not in the first quadrant. Let's try angles with this with values in the second quadrant. No? In this case, we are now going to use the reference angle. So with the use of the reference angle comes the sign of the functions. For the first three functions, in the first quadrant, all functions are positive. In the second quadrant, sine is positive. In the third quadrant, tangent is positive. In the fourth quadrant, cosine is positive. The rest are negative. To come up with a simplified, ano tawag ito? You can use the word ax. All, all positive, cosine, tangent, sine. Clockwise direction, you can just remember it, the word ax, for whoever is positive. All, cosine, tangent, sine. Or you can have it as ASTC. With a mnemonic, all students take calculus. Or you can just simply use the word ax. Without the triangle, you can use the values of 30, 60, and 145 using the special triangles with the property 1, 1 square root of 2. This is the property of special triangles, class. Or for a 30, 60, 90 degrees triangle, we can have 1, 2 square root of 3. But still, these values can be computed basing from Pythagorean theorem. No? So just remember the property for 45, 45 class. I don't know if that is part of your module, but try to copy that and put that in your index card. This is a property of a special triangle known as 45, 45, 90 degrees triangle with the sides that measures 1, 1 square root of 2. The value pi over 4 that is present in the frame is simply the conversion in radian measure of 45 degrees. No, that is the radian equivalent of 45 degrees. With the property again of a 45, 45, 90 degrees triangle as 1, 1 square root of 2. And for 30, 60, 90 degrees triangle class, the property there is 1, 2 square root of 3. 1, 2 square root of 3. Ayun. 1 as the opposite of 30 degrees, 2 as the opposite of 90 degrees, and square root of 3 as the opposite of 60 degrees. So if you're going to find the value of sine 60 degrees, so that is square root of 3 over 2, cosine 60, 1 over 2, tangent 60, square root of 3 over 1, or square root of 3. If you have the value for 30 degrees, sine of 30 degrees is 1/2. Cosine of 30 degrees is square root of 3 over 2. And tangent of 30 degrees is 1 over square root of 3, which is rationalized as square root of 3 over 3. Well, you can just type this in your calculator and it will give you an answer then. No problem with how you're going to find the values of these angles. Let's go to your module and let's try an item that we will solve. Choose between the activities in 1 to 10 and we will solve that item. And the rest of these will be done by you yourselves. Any item there that we will solve? Choose an item. Krisha. You think that the angle, you think of a very hard item in activity one. Wait, according to Krisha. How about Ralph?
Wait lang, sir.
Wait din as well. Wait, wait ng wait tayo ah.
Sir,
Yes, Krisha.
can we try number 7?
Number 7. Yes, we will do that. Number 7. Let's try this one. So from number 7, the given is sine of theta is equal to negative 2 over negative 2 square root of 5 over 5, where theta is in the third quadrant. Huh? So if this is your angle in standard position, theta is in the third quadrant. So if we are going to use the reference angle of theta, so this will be our reference angle. Right? Now allow me to draw a right triangle using the reference angle. What's the formula for sine? Opposite over hypotenuse. So therefore, this is the opposite value. This is the hypotenuse value. Which means that if you are going to come up with these values then in the figure, this is 2 square root of 5, the opposite of theta, and this is the hypotenuse. And since there is a negative sign and all modulus values are positive, so this is the negative value because of it being in the negative y-axis. Huh? This is negative y. Or if you don't like that, you can have the formula for sine theta, which is equal to y over r. And since there is a negative value, so the y there is the negative. So we have here your y, you have here your r. We are now going to find for x, you may use the Pythagorean theorem, or you can use the formula r squared is equal to x squared plus y squared. Since we are going to find for x, the formula then will be equal to the square root of r squared minus y squared. Sir, how to get that formula, sir? Manipulate the formula. Where is that formula, sir? This one. Where did you get that formula, sir? Distance formula. If you don't like that solution, you can use Pythagorean theorem because this is a right triangle. So if you're going to use the formula for x, to find for x, we get the square of 5, subtract it with the square of 2 square root of 5. The result is square root of 5. So x here is square root of 5. And since these values are square root of 5 and it points to the negative x, so this is negative square root of 5. So with that, we can have now the values as x is equal to negative square root of 5. Y is equal to negative 2 square root of 5 with r is equal to 5. Having all the values present, we can now solve for the trigonometric ratios of the angle in standard position. We have the x, we have the y, and we have the r. Question before we proceed.
Sir, how did you get negative, the square root of 5 again, sir? Negative square root of 5.
Raise. Drawing ko na kung tarong ha.
Take note, people, of the links where you found them. The links that you have there, take note, because these links will have to be used in the references section. Of course not, Alan. What you do is you read the entire legal basis and then perhaps get you could probably get the declaration of policy, or probably you would look at one term being defined. You would study the different sections, Alan, and you choose the one which applies to your work, your research. At least one.
Okay, so I hope this is enough in showing you the angle.
You might be
No?
surprised
So this is
things that are really unnecessary. Again, the decision falls into the hands of the researchers. But if the readers find that item to be irrelevant, you're the ones that
so this is your angle theta then. This is the theta part. This one. Yan siya.
let's
Okay?
talk about
And the angle terminates in the negative abscissa. So therefore, if you're going to have a point here, then your point of x will be negative and your y will also be negative. Question before we proceed. Again, we are now in the third quadrant. So the point that where the point where that angle in standard position terminates in the third quadrant contains the x's and the y to be negative. This is your modulus r from the distance of the point to the origin. Hello? Since the formula for sine then is
what about the other? Try to look for your entries.
here. Since the formula for sine of theta is equal to y over r, say, where are you, theta? Here. Is y over r. And the formula for your given is negative 2 square root of 5. Oh my God. Negative 2 square root of 5 over 5. Then it's safe to say that your y value from the given, your y is equal to negative 2 square root of 5. And your r is equal to, and your r is equal to 5. Math to ask a question again. Where did I get 5? This one. Where did I get 2 square root of 5? This one. Why is it that y is negative? Because in the third quadrant, y is negative. And take note, r is always positive. The modulus of a function is always positive. Take note of that. Since we have already now the values of your y and your r, let us find the value of x. To solve for the value of x, hindi mo na tayo tag-solution dire. From the formula, r squared is equal to x squared plus y squared. Diba that's the formula? Transpose y squared on the other side, we have r squared minus y squared is equal to x squared. Question before we proceed? And then later on, you might want to ask, where did you get that x, sir? From the formula again. Asa man ang r squared plus y squared? From the formula for modulus or distant formula.
International researchers regarding the population.
Are you with me, class?
That's good, that's good. Okay.
Okay, continue. Let's continue, huh? Let me rewrite the expression by writing on the right side x squared and on the left side r squared minus y squared. Ako na silang gibaylo, class. Wala ko ilang gibuhat. That is symmetric property of equality in math. Then, let's try to apply the square root of x squared. And in both sides, we will apply the square root as well. So here the square root of r squared minus y squared. Sir, ganong imo man ang square root, sir? Anong imo man ang gibutangan og square root, sir? Would you like to answer that question of mine, George? Ano ako mang square root na siya, George?
So we pray that the entries you added are really useful for your research. Lucia, James, and Chana, have you searched for related studies?
Because there's square, sir.
So that we will eliminate the square of your variable x. Yes. So we have x is now equal to, we can now eliminate the square root of x, but on the other side of the equation, we are left with r squared minus y squared. At this time, we can now find the value of x. X is now equal to the square root of, what is the value of your r? R is equal to 5. Sir, asa man ka nagkuha ng 5, sir? Nasa ibabaw. Tanawa lang palihog. So we have 5 squared minus negative 2 square root of 5 squared. Use your calculator and simplify the result by raising the values to the power of 2 and then get its square root. The answer for x is equal to square root of 5. Now you have the x, the y, and the r. You are now ready to find the values of your sine, cosine, and tangent. Since sine is already given, let's start with finding the value of cosine of theta. So in finding for cosine of theta, that's not theta. Let's apply the formula. The formula for cosine is x over r. The value of your x, can you still see it? The value of your x is the square root of 5 over r, which is equal to 5. So that is your cosine. Let's now move on to tangent. Tangent of theta is equal to, what's the formula for tangent? Y over x. Your y is negative 2 square root of 5 over the square root of 5 for x. Simplify your answer. Square root of 5 divided by square root of 5 is equal to 1. So the answer is negative 2 for tangent of theta. For cotangent of theta, cotangent of theta is equal to x over y. Your x is equal to the square root of 5. Your y is equal to negative 2 square root of 5. Divide the square root of 5 by the square root of 5. The answer is 1. So that can be simplified as negative 1 over 2 as your final answer for cotangent. Huh? For secant of theta, which having the formula of r over x, and for cosecant of theta with the formula r over y, then I will leave the answer to you then. You have here the solution, you have here the figure, or even the figure will not help. You have the given data. You can find the value of secant and cosecant.
Now I want to see a paragraph. Produce paragraph already at work.
Question?
Once you read
The square root 5, sir, it's not negative.
Yeah, thank you, Clarice. The square root of 5 is negative because this is located in the third quadrant, wherein the x is negative and the y is negative. Therefore, the x square root of 5x here is negative, so the solution then goes with negative square root of 5 over 5. Here we have negative 2 square root of 5 over negative square root of 5, so the answer is positive 2. And here we have negative divided by negative is also positive 1/2. Ayun. Thank you, Klang. That is negative square root of 5 for x because that is in the third quadrant.
to finish the theoretical background. You might have noticed that's the last part that we're trying to accomplish here.
Concerns? Question?
Take time.
Continue with second and cosecant class. I will not finish this one. Pwede ra na taplokon ninyo diretso sa inyong calculator class. For example, in tangent, o taplokon ninyo ng fraction sa inyong calculator. So we have negative 2 square root of 5 over 5, or rather over square root of 5 negative as well, negative square root of 5. It will really give you the answer 2 in your calculator. Tuplo ka lang og tarong. Diba? If you can see it from your perspective there. Akong spotlight. Spotlight ba? Ayun, no? Tuplo ka lang og tarong ninyong calculator. It will give you the direct answer. Ay, sorry. It's just that you are probably pressing your calculator wrongly, so you are now giving yourselves a wrong answer. Let's go back to the module and please ask a question.
For ST scoring purposes. Take note. Are you sure that the one that you submitted is already complete and fine? Alain?
So that is how you're going to do the other items in activity 1. Just focus on the module. This is the part where rationalizing comes in. You try to do that as well. And this is the part where the x and the y are negative in the third quadrant. You have to analyze that properly as well. And that ends our discussion for today. Any questions?
So, sir, it's